I'm Barbara Tharp with Baylor College of Medicine in Houston, Texas. And today we're going to look at 3 states of water. It's the third activity in the My World Teacher's Guide for Water. The objectives for the lesson are for the students to explore the states of water by making a water cycle. They'll make predictions, observations, they'll measure, they'll record, draw conclusions, all based on their investigation. By the end of the activity, students should be able to answer the question, what is a water cycle? The concepts that we want them to get from this are water can be found naturally in the forms of gas, liquid, and solid, and the introduction or removal of heat energy will cause water to change from one state to another. First of all, let's look at the materials. Non-expensive, but many household items. We have a plastic shoebox. We can either use a plastic shoebox or we can use a regular shoebox. We have foil, plastic wrap, a cup, sand, and a rubber band, and we put it all in a handy tray so that each group can pick up their materials from a central point. And we also have ice cubes. With that in mind, we want to make sure that students, before they start, remember to have you review the safety guidelines with them. There's nothing really dangerous about this, but it's always nice to start there. To begin with, we want the students to think about what do they know about water already. Where can you find water on Earth? To begin with, we live on Earth. Earth is 70% water, so it really ought to be called a water planet. There are 3 states of water, and by this time they should know what the states are, but in case you want to review liquid, solid, and gas, and what causes the change, and that's part of what we're going to look at today. And explain to the students that you'll be creating a water cycle model to explore the cycle and the states of water. To begin with, let's look at a model. And models are ways for scientists to explain other very difficult concepts. To make the water cycle model, we're going to start with the shoebox. And with the shoebox, what we're going to do is we're going to add a sand hill at one end of it. So we take our 2 cups of sand and we make a mound, like a hill in one end. With that in mind, we take the ice cubes, place them on the hill. Now what have we got? We've got solid water at this point in time, and we have our mountain. Now to make a closed system, we have to have some kind of a lid. The best way to do that is to use plastic wrap. With the plastic wrap, you want to cover your shoebox so that you have a closed system, just like the Earth is a closed system. Then you want to tighten it up. And you've got a closed system. Once you have the closed system, you want to put it in the sun and let the energy take over. As the energy takes over, you want the students to watch it over time. You want them to predict, when you put it in a sunny area, what's going to happen. Have them write that down in their notebooks and then observe it at intervals throughout the day. What I've done now with this is go to the next step. The Julia Child method. It has now been out in the sun. We have the ice melting. We have the precipitation on top. So what we've seen basically is the whole water cycle. So what happened to the ice cubes? The ice cube melted. How has the inside of the box changed? If you can look, you don't see ice cubes anymore, but you do see moisture and the sand is wet. The sand has little rivulets in it, so you can also talk about erosion. Where's the water in the box at this point in time? If you look at the top, you can see the condensation on the top. Whenever the condensation from the water vapor comes up, condenses on the top, enough of it gets up there, and what do we have? We have precipitation or rain. So we have the whole thing happening right inside the box. The continuous cycle. With the heat from the sun, giving the energy to go throughout the system, warm it up, change the ice to water vapor. The water vapor turns to condenses, then the condensation comes down as precipitation. We have the whole water cycle. So what are we looking at? What are the basics that we'd like for them to understand with this water cycle? To begin with, water exists in all 3 states, and we did see that with the solid, the liquid, and the gas, which ended up being the condensate on the top. That over time you want to remember that water changes very slowly. And if it didn't, animals could freeze up really easy, or the Earth's temperature could not be regulated the same way. And the Earth's temperature is regulated a lot by the fact that water does heat and cool very slowly. Water has a high boiling point, 212 Fahrenheit or 100 centigrade. Water freezes at 0 centigrade or 32 Fahrenheit. And another really interesting thing about water is that it expands when it freezes, where most things get much colder when they get much smaller when they freeze or get cold. With ice makes a crystal. The crystal spreads out so that it becomes less dense. And that's why when you have ice on top of water, you're not freezing the things that live below, the fish or the plants or whatever, because the water floats on top because it's less dense due to its crystal structure. What can we do with this? We can watch this year-round. You can leave this in the classroom on a window, and you will see the cycle happen over and over. We could also introduce a chemical spill. An easy way to do that is to put some food coloring in with the ice, and then watch what happens over time, and you'll see that the chemical spill, the food coloring, kind of starts going through the whole system. We could try to make it out of something else. What else could we do? We have one way we've recommended. We can do it with just a regular shoebox. If you don't have plastic boxes, you can take foil, line it, and you can put the plastic wrap on it and do it just in a regular shoebox. You can make it in a plastic bag. You can create a model that's sealed and one that's not sealed, and you can see which one works or doesn't. The basic bottom line is that students will understand that the whole water cycle, how it happens, and that it's a continual cycle, and that we only have so much water on Earth, and that's the water that we use over and over again.